maybe in the thing, in the scrolling thing, we're at BST in terms of the time zone.
Oh yeah. True. What, rather than GMT? Does it not say GMT?
No, well, we're BST, bro, right now.
Is that different to GMT?
Yeah, I think because it's basically British summertime.
Yeah.
Because I think it's to do with the clock and back and forward and all.
UK is not on GMT in the summer.
Oh, that's banging. The Twitter bot is actually
BST. It's good, isn't it? Yeah, I've got 24
Yeah.
followers. It's just a case of being active on social media, you know.
The following other people in this case. I mean, because you could tweet all day, right?
Yeah.
It doesn't get you followers. Though.
Yeah. Interacting with other users is the thing. It's like you're a node on the graph, right? And then you can do different actions, but some of them only interact with yourself, really.
Yeah.
Or they interact implicitly by going onto like people's searches and stuff. But yeah, like direct communication with them is just like making an arc between those two nodes. Yeah, it seems to work. We can make it do some more complex stuff soon.
Yeah. Oh my god, this fucking newsfeed is trash though.
What newsfeed?
The Hacker Hustle Twitter feed.
You sent that email.
Oh yeah. Yeah. By the way, the thing is kind of small now.
What, the screen?
The viewing window.
I swear I updated that. Why is it like that? Yeah, I didn't push it. Hang on. Yeah, let me just push the latest. Okay. What I need to do.
What's .idea?
I think it's a PyCharm thing. Don't need it though. It shouldn't be there actually.
Your virtual environment.
For whoever's here, I'm just fixing the site so you can view it better. Yeah, cool. That's more like it. Okay. Just gonna upload the latest version of this website for you. So this will be way better. Okay, cool. So yeah, if you're watching, you should be able to see it like this now, rather than the other format, which is pretty bad. So just refresh the page. If that doesn't work, clear your history, specifically your cache. So you can just do that in the history settings. If you're in Chrome, just go history, Control H, clear browsing data, clear data with this cached images and files clicked. I don't need to do that because I've got a cache killer. Okay. Alright, what are we doing? So, let's get started. So this is day 8 of the Hacker Hustle, day 8 of the month of ML. Basically today we're gonna show you how we can use some tools that we've built to make it really easy to rapid prototype with deep learning. It's basically tools that remove the boilerplate, which is the code that you just have to keep rewriting. For instance, like training loops, code to make your data loaders. We're going to show you how to use that, and then we're also going to show you another tool which can help you identify where in your programs there's bottlenecks and which might be slowing down your code, and then how you can address them. So to start with, this is the library which we're going to be using. So basically, if you come to my GitHub, and then you can find this repo, AI utils, it's called the utility tools, which we're going to be using. So you can just go there. You can take this this link, put it in your terminal, and then do. Have I already got it there? Yeah, so I've already got it there. But I could do, you want to do git clone that repo. So if you don't have git installed, well, firstly, if you run that, then what it will do is it will clone that this library into a folder in this location. And if you don't have git, obviously you can just do you can install git. If you're on Windows, you'll have to do it a different way, but if you're on Ubuntu or Linux, you can do sudo apt install git, and then that'll install git, and then you can install this library. Otherwise, what you can do is you can just download this as a zip file and then extract it so you have a folder which has this AI utils in. So then basically, what we want to be able to do is for our Python program to be able to read this library. So what that means is that you need to specify like this, or wherever you've stored this directory, this library, in a location where Python, you want to specify this directory actually as a location which Python looks for modules which you can run. So so basically to do that, what you want to do is add the location of this repo to your Python path. So for me, right, here's my home, and here's this library which has all the code which I want to run, which I want to be able to import into my Python program. So what we're going to do today is we're going to write stuff like, so looking at this library, we want to import, let's say, get data loaders, for example. And that is just a program in this file, which I'll show you how to use it in a sec. That's what we want to be able to do, but Python needs to know where to look for those programs. So basically, the way Python finds modules that it's supposed to be able to run is by looking in a certain set of locations specified by the Python path. So if you're on Ubuntu, again, you can print that environment variable, so just a variable which your operating system is aware of and that you can print in a terminal. So the way you get variables is to start with a $ in bash, and then capitals this variable, this environment variable, is called Python path. If I print that, didn't work. Oh, okay, yeah, cool. Because I just removed it actually, so that we could do this from scratch. So my Python path is empty. It's got all the default ones in there. So there's some default places where Python already searched for these packages, but you want to add something to that Python path. I've just removed it so that we can add it here. If you're not on Ubuntu and you're on Windows, like I'm sure you can just you can do add to Python path. Yeah, Windows, and you figure out how to do that. So there's probably a guide to do it. So you basically just you're able to go into here. You're able to create this variable name Python path. So it'll probably have some default ones already specified, and then you can just add another location. So the locations are separated by semicolons there, you can see. So basically you just want to change this variable. So well, basically these from the C colon backslash Python 27 / lib colon, everything before the colon, that's a location on your computer. And that's basically saying, okay, I want Python to check in this location for programs which I want to be able to use in my files, in my programs globally. So what you want to do is you just want to take that variable and then you want to go to the end of it and add a new search path in there. So in my case, that would be in Windows, it's your C is your home, so it'd be C colon AI_utils. And then when I run Python programs, Python would look in that folder, in that location specified in this Python path, for modules which it can import. In Ubuntu, it's it's simpler, I would say. So what you can do is just go into your terminal, and you could basically add to this Python path. One way to do that, the best way I think, is to use whatever editor you want, and go into your .bash rc file. So this is a file which is run every time that your computer starts up, or you open a terminal. One of those, is it? Every time your computer starts, bash rc. Let's have a look.
Yeah, every time your computer starts.
So when you log in, basically, when you log in on Ubuntu, this file, this .bash rc file, is run. So if we look inside it, it just has basically stuff which needs to be executed when you set up. So for example, some things are like, I've got these aliases set up. So I've basically said, oh, I don't want to type Jupyter Notebook every time I want to open a Jupyter Notebook. I'll just type JN. So I've defined that that JN as an alias for Jupyter Notebook. Another thing you can do is edit your environment variables like this. So I've said that my Python path is equal to the value of the Python path by using that $, and then also it's got a colon, which in Ubuntu is the delimiter, the separator for those locations. So it's going to get what's already in the Python path, and then it's going to append on the end of that another location, which is my home. So from my root in my home to AI_utils. Now my Python path includes this location, where Python will now be able to search for those files which we've downloaded. Okay. So now we should be able to use them. So what we're going to do today is basically look at the code which I streamed last, and then basically try and remove loads of it by using these libraries. Okay, so just to run this and see what happens here. It's like, okay, cool, we've got this function, we're trying to model, our green is the prediction of our input output, which we want to look like that blue line, and then the green is how bad our model is over time. So over time, the model's getting better, it's fitting the input-output distribution of the data better, and the loss in general is going down. And you can see that that shape is becoming more like what it should model. Okay. So, yeah, now let's just try and cut that down, because what we have here in this file is basically a lot of stuff that anytime we make a deep learning algorithm, we're going to have to write it anyway. For example, when we get our data loaders, we're always going to have to do that. But in this case, I just wrote kind of a single line demo. But in practice, what you want to do is you want to have a training data set, which is what you use to optimize your model parameters, a validation data set, which is what you use to compare different hyperparameter values like learning rate, batch size, etc., which you can't optimize directly like you can the model parameters. So basically use a validation set to try out different hyperparameters and then choose them based on which performs the best after training. And then you'd also have, let's write that firstly. So we'll say val loader, so just like a data loader, which is just basically something that gets our data set, splits it into batches and shuffles it for us. I would usually say train loader, validation loader is equal to, let's just copy this for now. So we'd have test, and then we'd also have validation loader. And these are basically going to be the same thing. You don't really need to shuffle them, but they will come from, in this case we just used the whole data set and gave that to one data one data loader, which was the training set data loader. But in practice, like what you might have to do, for instance, if you're using some of the data sets which are already in PyTorch by using torch.utils.data.datasets or something like that, then what they have sometimes is basically two different data sets. So they don't just have a data set which you want to split into training and validation and testing. They have like, okay, you can get the test data set, you can get the train data set, you can get the validation data set. So you might have like, you might have the training data set there, and then the validation set, and then the test data set. So instead of writing out those three lines, we can use something which is in this AI utils, and that is a program I've written called get data loaders. So what does that do, and how we're going to use it? Well, it's got this function in called get data loaders, and that takes in a data set, and you can tell it what batch size you want, and you can tell it a variable called splits. So basically, what this is going to do is we're just going to be able to write this. So we can forget about all of that. So this is the old. So that's the old stuff. And then we'll have the new stuff to replace that. Down here. Okay. So the new stuff which is going to go in there to replace this stuff, we're going to say, well, firstly we want to import that get data loaders. So we'll import get data loaders, and what that will do is it will put it will get this folder as a kind of object, and then that object has some functions which we can use. But really, they only want to use this function, or we can specify which functions we want from this module. Sorry for the confusion, they do have the same name, the module and the function within the module. So what we can do is we can say from get data loaders, import get data loaders. So that basically means from this module, import this function. So now we can use that function in our file over here. So what we're going to do is we're going to say, well, we're going to call that function get data loaders, and you can see it takes in a data set. So we've got the data set here. We made that earlier. Check out this code later if you didn't see that, but we're going to pass it a data set. We can tell it a batch size, and then we could specify the splits, and I'll show you how to do that in a sec. Okay, and well, what's that going to do when we get that? We actually want to get from that a training, validation, and testing data loader. So yeah, cool. Well, if we run this function, that looks like what it's going to return us at the end: training, validation, and testing data loaders. So we'll say train loader, validation loader, test loader is equal to what's returned from that function. And there we have it. just like we were getting our training data loader before by calling this data set, by calling this data loader, passing it the data set, telling the batch size, etc. We can do that for all the data loaders we want in one line. So now I will just I'll just comment that out. Cool, so we don't want that old stuff anymore. Okay, so now, but now we've returned train loader. So if this works as we want it to be able to, we should be able to use that directly in place of the data loader we were using before. So where were we using that data loader? Well, it was here. Okay, so let's just replace data loader with the new variable name train loader, and then run it and see if it works. And cool, there you go. So now we've cut down those 3 lines to 2, made it like a lot simpler. Oh well, a little bit simpler, at least to start with. But it just means you don't have to write the same thing over again. It just has exactly the same functionality. Okay, so let's have a look at what's actually happening inside that function when we call it. So, firstly, what's happening is it's checking if it's been passed as variable splits. Now splits, what that is designed to be is a list of the relative proportional sizes of the training, validation, and testing data set. So in this case, if splits isn't given, if it's none by default, then the splits is set to this, which is like a decent rule of thumb split to separate your data set into. So 0.8, i.e. 80% of the data set which you pass to this function will become the training data set, 15% will become the validation data set, and 5% will become the testing data set. So if you don't pass splits in, that's the default split. It just assigns a default to it. But you can separate them however you want. So we could say, for example here, okay, actually I might want my testing set to be slightly bigger, so we can say the splits is equal to this list. We'll say 0.75, 0.15 again for the validation set, and then 0.1 like that. Okay, well, now the next thing is that obviously has to sum to 1, right? So in this function, we've got this assert function, which will raise an error if the following condition is not true. So the sum of the splits should equal 1, right? Cool. Obviously, because it's proportional splits. Then what happens is we make a variable called train size, and so this is the proportion of the data set which you want the splits to have. So that's the 0th index, and that's the first element in the list splits, and then multiplied by the length of the data set. So we'll have 0.8 times the length of the whole data set. That will be 0.8, the length of the data set, right? And we round that to the nearest number by making it an integer. So this will be the number of examples which are in the training data loader and the training data set. Same thing. So we basically specify how many examples we want in the training data set, and hence then those ones are passed to the training data loader, so it's the same size. Do the same for the validation, and then do the same for the test. But a simpler way to do that for the test is, well, the training size plus the validation size plus the test size should add to the length of the data set. So just rearranging that, we can say the test set is whatever's left of the length of the data set once you've taken away the number of examples in the test in the training set and the number of examples in the validation set. Okay, so then we can take those. Then we can basically use this torch function, torch.utils.data.random split, to split the data set randomly with some given proportions. Now these are absolute values here, which is why we had to compute the test size, validation, and training size. And so what that returns to you, that function, is simply that data set split randomly with those sizes. So we get back from that train data, validation data, and test data. And then we'll have, and then just in this function, we're going to make the 3 data loaders, which we're usually going to want. So and this line here is literally just what we had here in the old. So here we were using that data loader function, which is from torch.utils.data. We were just using that to get back a training data loader. And so that's what we're doing here. We're just getting those 3 data loaders and then returning them. So yeah, like you can absolutely use this code. It's on GitHub. Just download it if you want to add to it, which I hope you do. It's probably not perfect. There's probably like more options and functionality that we can build into that. Please go ahead, and we'll be happy to like merge it and build it together. And we'll be developing it as well. So this will improve over time, and we'll put up a README file so that you can basically get a short, just markdown explanation of how it works. But that's that part done. So that's how we're going to use get data loaders, and there you have it. That's how we can just simply get the 3 data loaders in one line, and then here we can just pass that into, we're just looping for every element in that training data loader. So what's returned as a data loader is iterable, so we can just cycle over it and get different batches and batch indexes. Okay. And then we'll just train, take optimization steps based on our predictions for each of those and calculating the error. Okay, cool. So what else is in this library? Well, the next thing we're going to use is this file called training. And so in this, what it is a pre-written training loop, which is pretty general to any data set which has an input and an output returned from it. So what does this do? Well, basically we're going to say we'll train. So we're going to get a data loader, which we've got, probably our training data loader, and then we're going to go through every batch in that. We're going to unpack the batch, so the features X and the labels Y will probably be packed inside a tuple, which is the batch. And then, so ignore this timer stuff for the moment, because we'll get onto that in a sec. That's the next part, this profiler. But basically, yeah, so this is the standard training loop, which we've written a few times for the models which we've already trained. So what we do is we unpack the batch, we make a prediction for those features. We use some criterion, like the mean squared error, to compute the loss for our model by comparing the prediction and the labels. And then we'll use our optimizer. Well, firstly, we'll zero the gradients so that they don't accumulate over time. The gradients of our loss with respect to any parameters which contribute to it, or which the optimizer is tracking. And then we'll take an optimization step using those gradients. Sorry, not using the gradients. We'll compute the gradients of the loss with respect to anything that contributed to the loss, which PyTorch is tracking, and then using those gradients in those tensors which we've passed to the optimizer. When we set that up here, which is the parameters of our model, then we'll take an optimization step and adjust them slightly so that our neural networks are building more useful features to build more useful features from, to make predicting the correct output more simple. And then as we train, we'll print, okay, what epoch are we on? What batch index is this for this epoch? And then what's the loss for this run through? And then we'll add that loss onto the end of a list of the training losses we've got, and then we'll plot that loss on an axis. And then we'll update the axis. We'll update that figure, and then we'll continue. And here, like, this is just so if we can say, okay, if it gets to a certain index, then we can just break that easily by uncommenting that line. but not for now. Okay, cool. So let's do that. So at the moment, like, this is the training loop, basically. So we're going to replace all of that with one line. So let's comment that out. And then put what we want here. So we will import that first. So we'll say from training, that's the name of this module, we'll import train. So import train. And then we can do, okay, well, the training function trains for one epoch. So for every epoch, we'll train for one epoch. And the way we can do that is we can just put train. And then the model takes in a bunch of these, bunch of different parameters. Okay, so the first one is the model, which we want to train. In our case, we've called that NN for neural network. The next thing it takes in, oh, it's annoying, I can't see that anymore. So it takes in the model. It takes in the data loader. So in our case, that's the train loader. It takes in the criterion. So that's our loss function, and here we've called that criterion, as I usually do. It takes in the optimizer, then it takes in the, it's gone again. Okay, what does it take in? It takes in the optimizer, takes in what epoch we're on. So we're counting through the epoch, so that epoch is the index that we're on. Then it takes in a figure, which is the figure which you've got your loss plot on, which we've called fig up at the top there. And then and it also takes in the axis, which you want to plot your loss on. In our case, that's this loss axis. And then what else does it take? And then it takes in the list of all the previous training losses which have occurred over the whole training loop so far. Okay, so at the moment we've got this thing called losses. We're actually going to calculate the validation losses as well. So to be not so ambiguous, we'll say train losses. Equal to that, and then we'll pass in those train losses there. And then the last thing that that this function train takes in is a timer. Okay, so that leads us to the third thing that I'm going to show you from this library, which is this profiler which we've built. And so basically what this does is the profiler can keep track of basically the start and ending times of different events, and then every time that event finishes, so you call you call start and give it an event name, it will start that event, it will start timing it, then you call stop, and then you stop timing that event name, and then once you do that, it will add it to a list or to a dictionary, which basically shows this is the event and this is how long it took. If that event happens multiple times, it will compute an average, and then at the end, when you're done, you can call this function show, and that will show you what was eating up all the time in the code when that was running. So and then looking at that, you can identify, okay, here's what was taking up the most of my time, or here's what was being called most, and yeah, we'll take a look at we're using that in a sec. So that's basically what the timer is going to be. It's going to be an instance of this profiler. So before we put it in there, we need to import it. So we'll say from profiler import profiler, and what we'll do is we'll come down here. Actually, we'll just put that up here. So the first thing we do is we'll create our profiler, right? So I'll say p is equal to profiler. So now we've got our instance of this object, and it can do these different things. It's really easy to use. So you just, for instance, we can do something like this here. We can do p.start, so then we can give it an event name which we want to start. So what are we doing here, right? We're making the fake data, let's say. So we'll say making fake data. We'll copy that, and then at the bottom, after we've made that fake data, well, then we can call p dot stop. So we start that event, and then we stop that event. So what's happening when we do that? Well, when we start it, it's checking if that event is already in this dictionary, which is the profile of the code so far, and then what it will do is it will add one to the number of times which that event has been called, and it will also start timing that event. So it will say, okay, cool, the start of this event is equal to the current time there. And then when we call stop, it will make sure that event is in the profile, and then it will get the current time again, and then it'll get the current time, and then it will subtract the start time. So obviously that'll be the difference in between start and stop, which will be the closest, which will be the overall time it's taken between that start and stop call, and then it'll round that to the nearest 6 decimal places. And then basically it will look at the number of times that's been called, and then it will basically compute an average, and then when you and then eventually it basically sets the profile of that event equal to a dictionary, which tells you the average time taken for each call and the number of calls. Okay, and then when you do profiler.show at the end, it'll print you the time profile, and it'll go, so for every event that was recorded in the profile, it will print that event and the profile of the event, so the average and the average time taken for the call, and the number of calls. That's how that works, and it's just as easy as this to use. And then we could do p dot so profiler.show like that, and then we'll just break it there. That's in the wrong file, isn't it? That's the old file. So I'll just copy that and then undo all of those. Oh no, I'll put that all in here. Okay, anyway, well, this is the new code we're going to be working with then. Yeah, cool. Oh god. Okay, cool. Yeah, so we've got that profiler. We'll start making the fake data, stop making the fake data. So I just deleted that. So from profiler import. Okay, cool. So now if we run this, we get an error. Figure.canvas.draw. That's in training.train. What did I break there? Training.py. Okay, yeah, cool. Here, that's there. Cool. So right, yeah, cool. Yeah, we hit that K there, and here we got the time profile printed, right? So we had this. We started this event making fake data, and then we stopped that event making fake data, and then when we showed, it told us, okay, that's the event. That was the average time it took, and that's how many times it was called. So it was called 1 time, and it took 11,000th of a second. Sorry, 1.1 thousandth of a second. So that's how we can use that. Now, back to where we were at. So, yeah, we were down here, right? Well, now we can pass in that final variable, which that wanted was the timer, or the profiler, which we called P. Okay? So now we should be able to run that. Now, yeah, cool. So that's happening. You can see I plotted it in a different color, so we know we're using the right library there. But also, like this this training library is designed to be used for much more complex models than we can visualize. So hence it doesn't have a hypothesis plotting function in that. So we're not actually going to use this graph anymore because this can be applied to much more high dimensional data which can't be directly visualized in 2 or 3 dimensions. So we'll remove that plot from this code for the moment. So where does that come into play? Where's this hypothesis axis? We don't need that anymore. Loss axis is now just going to be in position. So row 1, column 1, first plot. Then we will just comment out from here down to here, where we're just talking about the hypothesis axis. So now we've just got the loss axis. Is there anywhere else we're using it? No, that should be good. So let's run that. And there you go. We can see that training over time. So look, we got rid of all of that now. Now that was quite a significant improvement. Now we just got one line in our training loop. So let's just push that down a bit further, get it out of our way. Cool, it's still there if you want to check it out though. Well now, we've trained for one epoch, and let's say every epoch we want to evaluate where how well our model is doing. So yeah, I just realized this is slightly unfinished, but we can finish it now, so that's fine. Okay, so basically, what is this evaluate function? Well, it's basically another, not training loop, but it's just an evaluation loop. So what we're doing is we'll take the model, and our model might contain some layers, for instance dropout or batch normalization layers, which behave differently in between training and test time. So the way we need to, we can set those models into test mode is by calling this .eval. Sorry. Cool. One sec, let me just send him the link to this. Cool. Okay, yeah, one sec. All right, cool. So now we, yeah, we're just looking at this evaluation of function. So we've got, we put our model into evaluation mode, which changes the basically the operation of layers such as dropout and batch norm into the mode which they should be used for inference, deployment, or evaluation, and then we just do the we loop through the data loader, which will be our validation data loader for this. We'll unpack the batch, we'll make a prediction using those features, we'll calculate the loss, and we're not trying to optimize the model parameters in the evaluation loop. So we'll just so we don't need the optimizer.zeroGrad, optimizer.step, loss.backward in this loop. So then we will yeah. So we're calculating so we pass in this list, which is going to be the validation losses, and we're going to append to that the scalar value of the loss which we computed for this batch. We're just going to take those that list of losses, and we're going to take their mean like that, and then we're going to scatter plot those that validation onto the plot. Okay. So yeah, wait. Let me just. So I'm just gonna write like a quick fix for this. AXH line. Right, so basically what this is going to do is it's going to plot a horizontal green line at the height of the validation loss, so we should be able to see that go down. What we should do is basically pass in what x position we're on, and then make a single scatter plot at the evaluation loss y position and at that x position of the batch we're on. So basically, we're computing the average loss over this validation loop, plotting it, and then after we're done, we'll put those layers back into training mode. So the dropout and batch norm layers, we'll put them back into training mode to switch their operation from evaluation into training mode again. Cool, so now we should be able to use this, right? Now we should be able to say evaluate, but we need to import it first. So also from training, we'll import evaluate, and then we'll put that here. So we'll evaluate the model, what does it take? So it takes in model, data loader, criterion. So the data loader here for the evaluation loop is the validation loader, obviously. Criterion, and then epoch. So yeah, it's not actually called model, is it? It's called NN. That's the model we want to evaluate. And then figure axis and validation losses. So fig axis val. So we'll make that variable here. We'll initialize empty validation losses like that. Yeah, it's called loss ax. And then we'll do validation losses. Cool. Alright, so let's see what happens when we run that. Got an error there. Okay, yeah, it's this AXH line. Let's not bother with that. It's a different file, sorry. On this. Cool. It's not applying in the right place, is it? So this is obviously what's coming from the evaluation plots. So we need to give it some x position because it's just plotting that as a scalar at the moment. So okay, well, just for a quick fix right now, we'll pass in some index, which this should be plotted at, right? So, which basically this is the index of how many batches have we done so far, which means we need to compute it here. So we will say that index is equal to, so how many batches have we gone through so far? Well, the number of batches which we've gone through here is going to be the length of the training loader. But then we might have already gone through that like several times if we've done it through epochs. So that's going to need to be times the number of epochs that we've done. So every time we're going through this loop, we're going through this many batches, and so we've done that epoch many times. So we'll just pass in this index here. And if we run that, what's happening? So we'll print that index, and then we'll print the mean validation loss, which is meant to be plotted against each other. So again, that's not what I want. Okay, so why would that not be plotting? What was the error? np.square root sizes scale factor in the scatter function. Square root not supported for the input types, and the inputs could not be safely coerced into supported types using the casting rule safe. Do you reckon that's because they're a different type? Do you reckon that's because they're a different type, that error? Like int and float? Or have a look.
It's not really fun.
Okay, so we'll just take that index and convert it to a float. And that is what we're plotting, isn't it? Mean validation loss. Maybe it's this G. Alright, cool.
Yeah, you have to do sequels for you and stuff.
Okay, cool, yeah, so it's probably not that. Oh no, okay, cool. Still that woman coming up. Alright, there you go. So these are our our validation losses over time, and they should be going down gradually with this loss as this is going down. It's annoying that spiked because you can't really see the downward slope so well. And there you go. Cool, that's actually not too bad of an implementation for that, so I might just... Yeah, I mean, you could pass in, like... Yeah, you could pass in the training loader. Nah, it's probably a decent way to do it. Okay. So there we have it. Training that model. There you go. Cool, so yeah, please like download this library, take a look through the code, understand it, and then contribute to it. Like, it's definitely lacking a lot of features. So whatever you think will be useful, make a request for us to make it, or make it yourself, pull it and then ask to merge it. And like, we'll be really happy to do that. So there you go, it's like quite a nice looking plot. And what else is in here? So there's some more stuff we're going to be building in here. One of them is to visualize your data, so data viewer, and then another one, some more stuff we're going to build. Anyway, that's all we're going to go over tonight. So thanks for attending day 8 of the month of ML. Peace out. We'll stay around for like another until 10. If you got any questions, so please ask on the chat. Please please give us some feedback. Let us know like how this could have been any better. Was there any parts that's not clear? Was there anything like, were you trying to follow along and you got stuck and we didn't cover what the error was? If there was, like, put it in the chat and we can debug it right now. But yeah, we'll just hang around and let us know if there's any questions. Shout out Rohan reviewing. What's that?
Just comment. You got Rohan.
What is it?
Did Rohan just comment?
I don't know. No, I just saw his message. Any questions? Cool. We can just watch that train a bit longer. Where's it down to then? Let's have a look. Let's make a better model. Let's make a deeper model. Whilst we're here, why not? So we'll copy that linear layer and the activation layer. We'll just make those in a layers match. So now we've got neural network going from 1 to 30 layers, and then 30 to 50, and then 50 to 50, and then 50 down to 1 again. See how better that converges. Or worse. Crazy. We can clip this. Let's clip it at 2,500. So we'll say loss x dot set underscore y lim 2,500. I don't know why it does that. You know why it does that? Why it flips the axis upside down? If you only specify a single value for y lim or x lim.
Set the height. Were you trying to set the height?
I was trying to set the y limit.
Yeah, I mean, I think it's because you need to specify both, and it takes min first.
Yeah.
You could be setting your min to 2,500. So you just want to set the max.
Nah, because it sets the max to 2,500, but then it flips the graph for some weird reason.
No, I don't know.
Yeah, strange. Anyway, yeah, just specify both if you want to do that. That's pretty noisy. Let's lower the learning rate just so it trains a bit more stably. It's going to be slower, but it'll give us a nicer curve probably. Yeah, any questions, like, please just ask. Still a lot noisy. Already got that. Yeah, you guys should do this. Just play around with it and see what helps it converge. Could actually bring back the hypothesis axis for this and just update it ourselves in that training loop. So think it's just got to get it better before it comes onto the Axis. Yeah. Obviously, whatever parameters I've changed have made it not train so effectively there, but why is that happening? Oh yeah, it's only plotting that every time it finishes both a training and evaluation epoch, right? So we won't. Let's just put that prediction before all this. That should work. Yeah, so this video will be available on the Hacker Hustle website. Just check that out. If there's any issues with the site or any features you want built or whatever, please let us know. And basically tomorrow we're going to start a week of computer vision. Is that right? Yeah, it is right. Tomorrow we're going to start a week of computer vision, starting off with convolutional neural networks for classification, residual networks, detection, segmentation, and we'll probably show you a few other things along the way as well. That should be pretty cool. And also, please sign up as a follower on our Twitter. That's exactly where the best place to keep updated with all of the updates of what's happening when. So just go to Twitter and search the Hacker Hustle. And there's a link for that in the chat. And also, if you want to spend your summer or spend any time or even just learn and not really do anything with it, if you want to basically build some AI powered web app which you could launch as a business, you're interested in learning, okay, well, how does this stuff actually translate into a real product that can be powered by AI? How do I build it? How do I build it on an app or on the internet, both using the same techniques? And how can I use it to make money, and how can I reach customers? If you want to hear more about that, then just look in the chat as well and find a link to the event which is happening this weekend. And that's basically the first part of a series of workshops on how to take an idea and build it into an AI powered web app which can serve real users. So yeah, do sign up for that. And that'll be like workshop format over a few hours on a Saturday. Cool.
We're done actually, so
We're done.
Get my card anyway.
Yeah, cool. Nice one. Another good session. Yeah, 1 minute to go. We'll do that. Yeah.
Cool. Yeah, good session.
Alright, yeah, Hacker Hustle, month of ML, day 8 complete. So peace out. Alright, enjoy yourselves.